b vector t. Boo. Okay, plus sine of t up top and t down bottom. It's just gonna keep popping up. And just to double check. All right, that's going to be a pain. Alright, so there's a question. I think the answer is yes. If we also include I can't use C because that's part of the null space. Had to use C. Right, D vector times a constant, in other words, just times 1. I think we need to include this because in addition to having, okay. Right, if we start with a polynomial, you should then have to include all subsequent terms in that polynomial leading down to our constant. In this case, because our derivative of this thing could potentially knock out that term. Right, it's possible. So we're going to have that. Alright, then x sub p is going to be this exact same thing again. That's not what I want. Right, take this, get rid of that, and then move this one over. At prime. Okay, a sine of t is going to be a cosine of t. Oh, is that another thing? I may also need to include a cosine of t in the original g. Yeah, I do. Alright. Let's try again. Okay. So we're going to make a sine of t plus b cosine of t plus j, I know, times t plus k times 1. Okay. Nope, that was not what I wanted to... Why did you open a new tab? That doesn't make any sense. I mean, I must have hit something. Nope. Alright, hang on. There we go. Okay, copy again, paste again. Put this in here. Right. So this is going to be A cosine t. Plus, that's going to be a minus B sine of t. And then plus J. And then that's times 1. Our K vector gets cleaned out because, again, we're taking the derivative of 1, so that's 0. Is equal to Alright, so in this particular case, we get, this is going to be a 1a1 plus 2a2 Alright, multiplied by our sine of t plus 1b1 plus plus the 1 also from here. Need to move all that stuff. Now you know what, we need to move all of it, so sine as well. That parenthesis as well. Alright, plus 1. Alright, b1 plus 2b2 times the cosine of t plus j1 plus 2j2 times t plus k1 plus 2k2. Alright, we'll lead on to the fact that that's gonna also be in there. Alright, second one is going to be 2a1 plus a2 sine of t plus parentheses 2b1 plus b2 cosine of t plus j is going to be same deal here. It's still 2j1 plus j2, however, not vector. We're inside of a vector. Plus j2, but now we've also got the t at the end, which is going to contribute a 1 as well. So that's plus 1 all times t, plus parentheses k, 2k1 plus k2 times 1. Same deal there. So now we get all of our separate systems of equations that are working together on this. Okay, the sine term is going to be a -1, and that's relating b's. Crap. Our sines and cosines are relating to each other, so this is less helpful, but still does something. Okay. So for sines, we get a1 plus 2a2 plus 1. It's going to be equal to, this was all nope, negative b1 minus b2. No, it's just negative b1. Never mind. Negative b1. Okay, that's sines. For the second one, we've got a negative b2 is equal to 2a1 plus a2. For cosine. We have an a1, a2. Oh, come on. No, don't freeze. All right. Well, that seems to have completely killed everything. Cool. Yep. It's dead now. Cool. Thank you everybody for coming. I'm going to utilize my moderator portion over here and try to send us somewhere. Who is on tonight? Dr. Gold is on. Yeah. Alright, so we're going to go over to Dr. Gold's stream because my stuff just screwed up. I no longer have control over... Oop, nope, there it goes. Alright, cool. Works now. Man. This is just all sorts of fun. Alright, we'll try and finish this. So, A1, A2 are respectively equal to cosine portion. B1 plus 2B2 and cosine portion 2B1 plus plus B2. Okay. T. We have on the left none. So 0 is equal to the following. So on top, our T's are J1 plus 2J2. And down bottom, we have 2J1 plus J2 plus 1. Okay. And our constant. Is going to get us, right, zeros. Nope, we have J1 and J2 on the left, which are then going to be equal to, top one constant is K1 plus 2K2 that's it, and bottom is going to be 2K1 plus K2. Alright, so we know the values of J1 and J2 on the left, which then we'll be able to transfer over to the right and get the values for K1 and K2. So here, this is going to be J1 can be replaced by negative J2. Negative 2 J2. So 0 is equal to 2, parentheses, negative 2 J2, plus J2, plus 1. This is a negative 4. J2 plus 1 J2. It's going to be negative 3. Move it to the other side. So we get a 3. J2 is going to be equal to 1. Therefore, J2 is equal to 1/3. And if J2 is 1/3, then we get J1 is going to be negative 2/3. Negative 2/3 is going to be equal to K1 plus 2K2. And J2 was 1/3. 2K1 plus K2. Multiply this row by negative 2 and add. We're going to get a positive 4/3 plus 1 is going to be 5/3. Okay, plus a negative 2K1 plus 2K1 is going to be 0K1. Minus 4K2 plus 1 is going to be a minus 3K2. So it looks like K2 is going to be a negative 5/9. And K1 is going to be equal to negative 2K2, so that's going to be 10/9 minus 2/3, which is 6/3. So this is going to be a positive 4/9. Ridiculous. All right. Alright, A1 is going to be equal to, rewrite all this stuff, it's going to be a negative 2A2 minus 1 minus B1. A2 is going to be equal to, that's not going to be helpful, so we need to get it in terms of the other one. A1, you know what, fine. 2A1 is going to be negative A2 minus B2, so negative 2A1 is going to be positive of those. So up top, this is going to be negative 2, that's A2. No. We wanted that initially. Just okay. We wanted A2. Negative 2A1 minus B2, which means that A2 is going to get replaced. This is negative 2 times the quantity, negative 2A1 minus B2. Minus 1 minus B1 is equal to. Alright, A1 is equal to 4A1 plus 2B2 minus B1 minus 1. Okay, so 3A1 is going to be equal to B1 minus 2B2 plus 1. B1 plus 6B2 is equal to B1 minus 2B2 plus 1. At this point, we want to keep all those things separate. We don't want to deal with any more A2s. Now we're just down to B1s and B2s. But at the same time, right, now if we plug in pretty much anything, it's going to get in terms of A's again. 2B1 is equal to negative 8B2 plus 1. I'm not sure that I'm going to get anywhere with this. So one of the things that we can do is to plug this all into a calculator and ask it for the row-reduced echelon form of this particular matrix. So we're going to want this to be a 4 by 5, I believe. We have 4 different equations that all have A's and B's in them. What we're going to want to do is to move everything to one side, unless it has a number, in which case that's just the first matrix. And we'll go in order. So A1 is going to be a -1 if you, sorry, move it that way to get away from the 1, which is by itself over there. Then A2 is going to be a -2, B1 is going to be a -1, and B2 is a 0, and then we have 1. Alright, next equation. It's not going to matter. Let's move everything to the right near the A's. So A1 is 2, A2 is 1, B1 is 0, and 1 B2 when we move it over equals 0 because there's no constant. Cosine, we got a 1 for A1, 0 for A2, -1 for B1 because it has to move over with the A, -2 for B2, and 0 constant. Alright, 0 for A1, 1 for A2, -2 for B1, and -1 for B2, no constant. Then we go into math. Nope, we go into matrix. Math, REF of matrix A. Woo, it worked. Alright, A1 is equal to 0.1. It'll just go with fractional form because it makes a little more sense. Right, 1/10. A2 is going to be equal to -4/10 is 2/5. B1 is equal to -3/10. And B2 is equal to 2/10 or 1/5. Okay, so that means that our overall solution for this is that X bar is going to be that stuff first, homogeneous solution. Sorry, C2, 1, 1. did the 3t. Okay. Plus. A is going to be 1/10 times the quantity 1 - 4. And this is not E. A was... Yeah, actually it is, right. A is a sine function. Okay, plus 1/10. -3 by 2 cosine of t. Plus. J is our t function. So this is a 1/3 -2(1) times t plus 1/9 4 -5, and that's constant, right? Just times 1. Right, that is everything all the way through. And again, here we did use the method of undetermined coefficients. It makes it a little bit easier to work with. We could have used matrix stuff, but again, at this point it's getting really kind of ugly to work with all the little things that are in every individual term, or each individual term. So it gets pretty complicated when we get into it. I prefer undetermined coefficients wherever possible. There are still several different forms or different ways in which we can find our non-homogeneous solutions. So we'll get into more of those as we get further on. That was not what I was expecting. Oh, okay. I thought we did something else, and then, no, it's just, never mind. Alright, let's, probably still head over to Dr. Gold's. Let's see who is on. So the 9 is tonight working on the smoothest churro. Balint is going to be starting up on Microscopy Monday pretty soon. Dr. Danny Anduza is back from his dig and is now looking at the Utah dinosaur that they had. That they dug up. Irish John Games is currently working on Rise of Piracy and just about to finish this first game, so anybody who is into escape rooms and things like that. Wow, no, that is a completely different thing that I was looking at. Sorry. Anybody who might be into like piloting a pirate ship and firing cannons and doing things like that. Irish John Games. It's a good one for that. And yeah, we'll go see Dr. Gold. Been on for about 40 minutes, so makes sense. Those of you who are in the have been on his list, he does SAT prep questions, and he is Going to be doing a quiz style sort of game show. So everybody head on over there and we'll see you. I will be back probably tomorrow to do some mathy type stuff. On Wednesday to do our next class of differential equations. And then I'll be back probably on Friday to play some games. Maybe some other time in the meantime. I have no idea. We'll see what I'm feeling like on any given night. So.